Good afternoon, class. Today we're going to be learning exponential growth functions 6.3 and 6.4, part 2.
Thank you, Will. All right. Somebody remind me for exponential formulas, or functions. What's our formula? It's not mx plus b. That's a line. Sydney?
Is it y equals ab x?
Yep. Y equals ab to the x. Perfect. So we talked about that in the warm-up. Let's see. How would these two graphs compare? One is y equals 4 times 5 to the x. The other one is 5 to the x. What does this 4 do? Yep.
It's like it stretches the graph by 4.
Yeah, it would stretch the graph by 4. So I tried to show you guys that as a picture. If you stretch it, it curves up sharper. Okay. How about that one? This time you're comparing y equals 5 to the x and y equals negative 4 times 5 to the x. Yep, Xander?
A vertical factor stretched by 4 and flipped over the x-axis.
So it's going to stretch out by a factor of 4 and it's going to reflect over the x-axis. Why do you have this extra step about reflecting?
Oh,
Yep.
because it's negative.
Right, because there's a negative in front of the 4.
Can you say flipped?
You can say flip or reflected. Yep. Flip or reflected. All right, so now, we didn't deal with this case yesterday. This is on your guided notes. Okay? If A is between 0 and 1, okay? We looked at cases where A was bigger than 1. So if it's bigger than 1, the graph stretched out. It got taller. What do you think is going to happen if A is between 0 and 1?
Maybe it'll shrink.
It's gonna. So someone says maybe it would shrink. Yep. Or compress. Exactly. That's what's going to happen if A is between 0 and 1. The graph compresses. The graph ends up being compressed. So here's an example of that. Here's your original. Okay, let me make a copy of it. Let's make it a different color. Let's try that. Okay, here's an example of compressing. I go like that.
Oh, it's smaller.
And now line them back up.
Whoa.
What do you notice about the curve in red now? Is it as sharp as the one in black?
No.
No, it kind of flattened out a little bit.
It's worse than the other one.
So the curve in red,
Yes.
the curve in red curves up slower because you compressed it. If you compress it even more, okay, watch what happens. The more you compress it, look what happens. Now the curve is even flatter. It still curves, right? Does everyone agree it still curves?
Yes.
Still curves, but it's much slower. Okay? Now, the way we're going to have you guys write that, so you can use the same type of thing you did yesterday, we're still going to stay stretched, but we're going to stretch by a half. If you stretch something by a half, think of what that would do. Half is smaller than 1, right? So stretching by a half really compresses it, right? But if we have you guys write compressed, it's going to be confusing. So,
You want to change that? You want to change that wording to here?
We're in the
yeah. So,
I don't know what to do.
so when a graph is compressed, this is how you'll write it. Vertical stretch. And if you're like, wait a minute, whoa, he just said compressed. Why is he writing stretch? Hold on. Vertical stretch by, or actually factor of, A. Now, the key that's going to make this a stretch is A is going to be a number that's less than.
What two numbers is it going to be between?
Oh, 0 and 1.
Right. So-
a fraction or a decimal, proper fraction or a decimal.
So by having you guys write it this way, you can use the exact same wording as yesterday. You're still going to write stretch, but the difference is when you stretch something by a decimal, it really compresses. It's kind of like if I said to you, I'm going to add -2 points to your grade. If I say add -2 points to your grade, am I really adding points to your grade?
No,
Yes.
taking away 2.
Right, I'm really
Adding a negative number.
I'm really taking away 2 points. So when you tell me, hey, stretch it by a half, you're not really telling me to stretch it. You're saying stretch by a half, it's really going to compress it. So this is a proper fraction or decimal. Less
Where
than
it says
1.
written.
It says in red, like when you
I saw that little.
Less than 1 and greater than 0.
You guys, you kind of already have that anyway, so don't worry about that too much.
Okay.
Again, it's not really gonna change when it's greater than 1. I'm sorry, greater than 0 and less than 1. It's really not gonna change the way you write it. It's still gonna be written the same way.
Now, what do you think would happen if you had a problem like this? Here's the original. And now we've got -1/2 to the 2x. How many things are happening here if you base it on what we did yesterday?
Oh, you have to flip it, so then it'd be 2 times 2, so it'd be 4.
Well, that's going to cause a flip. What about the 1/2? How would you write that one down? Yep.
2 over 1.
No, we don't have any negative exponents here, so we're not flipping anything.
You're just keeping it the same.
You're keeping it the same, you're just writing out what is the 1/2 going to do.
Remember yesterday,
Oh, 1/2 the second.
remember yesterday, guys, when we were doing the comparisons and your A was negative. What does a negative what does a negative cause the graph to do?
You have to flip it.
So we got that. What about the first part? The negative is the flip. How would you describe the 1/2?
Less than.
Oh, you have to stretch it, but it's not really stretching it. It's like
So-
Yeah, it's still written the same way.
So what would you write? Like on the test, what would you write down?
Your answer.
It's being compressed by 1/2.
Don't say compressed.
That's not what it says to write.
Well,
Stretched by a
but
factor
it's-
of 1/2.
Stretched by a factor of 1/2.
Compressed, though.
Yep.
And remember, guys, when it's negative, you're not gonna write by a factor of negative, whatever the number is. Make sure you keep it positive.
If you want to write compressed, you can, but it's going to confuse you what I'm about to say. If you want to compress it, you have to say compressed by a factor of 2.
No.
That's going to probably confuse you.
Yeah.
You can stretch it by half or compress by 2. It's the same thing, but we're trying to show you how to write it using what you did yesterday. So I would write stretch by a factor of a half for this one, and
Oh, and something.
Multiply it.
And
And
flipped,
Why is it flipped?
Because it's
X
negative.
axis.
So negative number.
Perfect.
flipped, hold on, we're not there yet.
Flipped where?
Over the
Underneath.
X-axis.
Over
Not flipped over 1.
Over the
Underneath
X-axis.
the negative.
Flipped over the x-axis. Alright,
So where are we writing it for the negative?
So guys, on your thing when it says, if it's a negative, don't worry too much about that. Or it says written like, it's gonna be the same thing as yesterday. Vertical stretch, so you'll start with written like, vertical stretch by a factor of A, whatever A is.
Yeah, that was the first one.
And I'm adding to it. I'm getting lazy, I don't wanna write this twice.
This is what?
And flipped over the X-axis.
Reflected over so vertical stretch by a factor of whatever A is, and reflect. So guys, it's the same wording as yesterday. Alright, but the reason why we're doing it today is because yesterday, when it was vertical stretch, it went up really rapidly, right? It got steeper really, really fast. Today it's getting more, what's a word I could say? I guess less
the
steep.
curve is flattening
Yeah,
out.
it's flattening out. There you go.
Yep.
I don't even know.
So whether A is a number greater than 1 or A is a number between 0 and 1, your wording will be the same. It'll just make it, the graph will look different, that's all.
Okay, so tell me what's happening here. If you compare y equals 2 to the x and y equals 3 times 2 to the x. This is kind of like a review from yesterday.
Yeah.
Yep.
So it's
I get it.
the 3 is going to make it go. Wait, the 3. It's being stretched by 3.
Yep, which way?
Vertical stretch by
Vertical.
I know.
Stretch by a factor of 3. What does that mean?
It's being stretched up.
What would happen to the curve?
It would like.
So you have two choices. Is it getting flatter or is it getting steeper?
Steeper. Remember when I stretched it? The curve went steeper, and when I flattened it out, the curve was more flat.
How do we know that it's going to get steeper?
Because it's not a negative.
Well, the negative means it's not going to flip.
Yes, there's a positive.
It's a positive number, but what else?
What kind of number would that have to be to compress it?
Oh, it'd have to be a fraction.
You have to be a fraction less than
Oh, yeah. 1.
less than 1.
Remember, if it's between 0 and 1, that makes it get steeper. That makes it get flatter. If it's more than 1, that's going to make it get steep. That's going to make it get steeper.
Okay, so what's happening here? Gemini?
Isn't like a vertical
It's example number
by a factor of 3.
Vertical stretch
We're on example 1 right now.
by a factor of 3. And what else?
You reflect it over the.
And reflect, some people say, can you say flip? It means the same thing. Reflect over x-axis.
I hate this.
Paige, how do you know when it's reflected?
Because it's a negative.
I don't care what kind of a number it is. I don't care if it's greater than 1. I don't care if it's between 0 and 1. If it's negative, you have to put reflected over the x-axis.
Now, besides reflecting over the x-axis, is the curve here going to get like a sharper curve, or is it going to flatten out? Sharper, right? Look at the number. The bigger you make that number, the sharper the curve is going to get. Okay? What kind of number does that have to be for it to flatten out? A fraction. So that's what's going to happen here. This is really going to flatten it out. But how do we write it?
Oh, the vertical factor stretched by factor of 1/3 and flipped over the x-axis.
Vertical, can you say it again?
Factors. A vertical factor stretched by
Vertical factor.
stretched.
Yep, we're stretching vertically.
By a factor of 1/3 and flipped over the x-axis. Say if you word it wrong, instead of it's taken off.
Just word it close to that.
Well, I said a vertical factor stretched by a factor of 1/3 flipped over the x-axis.
That's okay.
I forgot.
So vertical stretch by 1/3. Now, someone said, well, can you say compress? Yep, you could say it compresses by a factor by 3. I would just stick with doing it this way, and you don't have to worry about that. So yes, it does compress 3 times as much. So think if it's like this tall, and it compressed 3 times as much, it's that tall. Okay? But that's an easier way to do it. And is there anything else happening?
If and flipped over the x-axis.
Why is it flipping over the x-axis?
Which one?
1C.
You just take the
Something's
negative
flipping
away.
over the x-axis.
You took the negative away, right?
No? No, the last thing I did was move the slide down.
Oh, sorry. Sorry.
You know what raises butterflies?
That's it.
That's it. That's all it does.
I'm 1 second.
But there's
sorry.
one more. Noah, read the back. Raise butterflies.
Okay, let's look at this one. Noah, what's happening here?
It's a negative.
Okay, what's the negative going to do?
It's not going to make it vertical. Well, it's going to make a vertical stretch, but it's not going to really stretch.
Can somebody remind Noah, what does a negative do? One word, you could say one word. It causes the graph to
Reflect over x-axis.
flip.
Oh, flip.
So we're gonna write that. You could write that now. We usually write that one second. What's the first thing we write? Vertical stretch by a factor of 1/3. So when you stretch it by 1/3, that means it's really doing what? It's really flattening. It's really flattening 3 times as much. So vertical stretch by 1/3, and Noah said it. Reflect
Over x-axis.
over x-axis. Okay. Any questions on that? A factor of 1/3.
1/3. Let's go to the next page.
Yeah, I think the next one is the butterfly one.
Whoa, whoa,
No
whoa.
one's butterfly.
Yes.
Oh, no, Grandpa. This is about
Full of the butterflies.
The thing is like mine is commonly used.
What the hell is this?
All right, so let's look at example 2. Okay, example 2, it says, Noah raises butterflies and buys 5 butterflies to start. Each year, the number of butterflies triples. Okay? Now, if you get a problem and it says that something is doubling, something is tripling, something is quadrupling, that's exponential. What that means is eventually the amount of things is going to go up very fast. Okay? So this one says every year the number of butterflies triples. Write an exponential function for this problem. Now, when we have to write exponential functions, we've never been given it as a word problem. How has it always been given to us?
An equation.
Well, we have to come up with an equation from a...
Well, it's in the y equals abx.
That's what we want to get. And what are we usually given? A chart. We're usually given a table. So let's make a table. Okay. So our table, y is going to represent years, and b is going to be number of butterflies.
So you have to make a chart for this?
Where should I draw the chart?
Where you want.
Wait, how can we come to this already?
So y is going to represent years, b is going to represent butterflies.
Anywhere.
You can put it anywhere you want.
Oh, we have to.
I'm sorry, Nathan.
Okay, right now.
I keep bothering you.
No, it's not.
How many
We're plugging in our numbers.
No, it's not.
how many butterflies does Noah have to start?
5.
5. How much time has gone by in this problem when he has 5 butterflies?
3.
Wait, no.
3
No. Every year, no one has
triples.
Guys, one at a time.
Oh no,
Where
what's
are we
yours?
writing
Like
this?
5.
We already said that here.
Oh, I'm sorry.
Example 2.
It depends on how many years there are.
Takes no
Man, this class is not on.
Guys.
Joe, you never talk, right?
I never said that, did I?
The same.
I know. Never said I was.
I'm triggered.
I'm not arguing. Not the business of arguing with kids.
Just
So
wasted time.
we're trying to figure out when Noah has 5 butterflies, how much time has gone by at that point? We'll call this an experiment. So after a year he has 5 butterflies?
No.
After a year, he has
You
15.
don't know when it's.
So guys, at this point, how many years have gone by?
I don't know.
None.
None.
None. He starts with
Right
5.
now, he's starting his butterfly hobby.
Day 1, he goes to the store, buys all the butterflies, no time has gone by. He starts with 5.
Grandpa, you can have that.
So after 0, think of 0 as the starting point. He has 5 butterflies.
Okay.
Now, after 1 year has gone by, what happens to the number of butterflies?
So he has 15.
Triples. And let's just do one more. After 2 years.
But I don't know what 15 times 3 is.
How many points should we make? Like,
What's 15 times 3?
I don't know.
45.
No.
like,
Okay, so now what I've done here is I turned this into a problem that you saw yesterday. Now you have a table. What's your formula for an exponential curve?
It
Y equals
is.
A times B.
Y equals A times B to the X.
Maybe X.
And I'm hoping that I wrote it as a table, now you recognize what to do. How do you get A?
It's,
Oh,
it's
Zero.
the 5.
It's 0.
Go to 0,
And then it's 5.
look down, and it's whatever number is with the 0. I know our letters are different this time because we're using B and Y for butterflies and years. Look at the 0, pick the number that's with it. So A is 5.
5.
How do you get B? Yeah?
In the B column, you see how much it increases by like multiplication,
Right.
which is 3.
In this column, check what you multiply by each time. Multiply by 3.
Y equals 5.
One more thing I need.
The X.
The X.
No, what is?
That's the formula that you would use to figure out how many butterflies Noah would have at the end of X years. Let's check it for 2. If you plug in 2 years for X, what's 3 to the second power?
9.
9 times 5?
45.
45. That's exactly how many butterflies you should have.
Guys, what if we asked you how many you had at the end of 5 years?
You would just keep timing it by 3.
You could do that, or you already have your formula set up, right? X. All right. You can plug in here as well. All right, guys, please stop. Thank you. You all set? It shouldn't take that much to pick it up, though. I don't know if you're making tug of war with your pencil. I don't know what you're doing.
Yeah, it's my pencil.
I'm confused. No, that's her, not me. I went like this.
You got it. All right. So again, like X said, if you wanted to just do 45 times 5, and then do it one more time, you can do it that way too.
What about, what if we said after 40 years, how many butterflies? You don't want to times it by 40 times. It's going to take forever.
Then what do we do?
What would you do? If we said how many butterflies would Noah have, what did I say, after 40 years?
Yeah.
How would you figure out after 40 years?
I would do 3 times 3.
You would probably fill in like.
Fill in something we just,
Yeah.
what would you
Would it be
fill
the
in?
X?
Fill in what for X?
40.
40. Just
Oh, I was right.
type that in on your calculator.
To the 40th power.
5 times 3 to the 40th.
Times 3 is 135.
What's going to be in the billions?
Yeah.
It's
And again, guys, you may get this formula all set up and ready to go, and it'll say after a certain amount of time how much will you have. The exponent is always going to be what you're going to plug into. Right? Just like yesterday when we did the graph, we plugged in a number each time for the exponent, right? That's what changes it, right? So you may get the function already set up, just plug in a number. That's all you have to do. All right? If it's already given to you, don't do more work than you have to. In this case, we had to figure it out first. All right? So a little bit different from yesterday. All right? We're gonna use a formula today to figure out some word problems. All right? Again, the function, right? We talked about yesterday, a b to the x. Right? Again, what does this mean? What does this mean?
A is greater than
A is greater than 0 and
B is greater than 1.
b is greater than 1, right? That's called exponential growth. Mr. Hager showing you guys an example, right? It goes up, starts off really not much growth, and then goes up really rapidly. That's what exponential growth is. Look at the graph. It goes up to the right, because that's where the positive numbers are, right? You want exponential growth to be positive. It's going to start with fractions, and then it'll become whole numbers. Just like we did slope, right? It goes up to the right. Right? We want exponential growth to be positive. We're not looking at negative numbers, we're looking at positive numbers. Right? So Fred, exponential growth is always going to be what kind of numbers?
Positive number.
Positive, very good. Alright? Alright, so now we're going to use another formula, alright, for exponential growth when we're doing word problems. Alright? So on your notes, you have that big box which says y equals, and you got a couple, like 3 arrows coming out of it. Alright? So First thing will be on there is just like before, A. A is your initial amount or your investment. Just like we did y equals a times b to the x. A was what y equals when x was 0, right? The beginning, what you start with. Same type of idea here. What are you starting with? How much you putting in? How much you investing in the start? That's going to be your A. Then we'll have, you guys have the parentheses. First thing in your parentheses is 1, and you have the plus sign. 1 is just part of the formula. That's just how it is. All right? 1 is just part of the formula. R
Is rate.
Yeah.
Rate of growth. Rate.
R is going to be your rate. Oh, I'm sorry. It'll be the growth. All right. This you're going to know its rate because it's going to be as a. Sorry, Mr. Hager.
Jab on the haters.
Will, please.
I'm
actually going to commit.
Alright? So guys, you're gonna know its rate. That's gonna be when you're reading the problem, that's gonna be as a percentage. Alright? The number you're gonna know its rate because it's gonna be as a percent. Now, alright, when you plug it into the problem, you wanna make sure you change it to a decimal. Or if you're doing your calculator, you want to make sure you hit the second button and then hit the percentage button. So if we, like Mr. Hager showing you guys, if it was 32%, to make it a decimal, it would be 0.32. Alright? If it was 5%, right, make it a decimal becomes 0.05. So to make something a decimal, all you want to do is move the decimal point 2 places to the left.
I learned this in 6th grade. And we had a
So again, remember, your rate is going to be a percentage. You have to change it to a decimal. What did I just say, Fred?
You have to change it into a decimal.
Change what to a decimal? Change what? How is the rate going to be written in your problem? How are you going to know what's the rate? What's it going to have?
That's decimal.
Not decimal, no. You have to change it to a decimal.
I don't know.
It's going to be as a...
T.
It's right there.
A percent.
You know what?
It'll be as a percent. Alright? And then T is going to be your time. In most cases, it's going to be years. Sometimes it'll be months, but in most cases, for the problems we do, it'll be years. Now, you got to pay attention, because sometimes we may just ask you guys just to set up an exponential function. You don't have to solve it, just set it up. Which means we won't give you the amount of years. You'll plug in everything else and just keep T as T. Because then you could use that exponential function. If we gave you any amount of years, you could just plug them up. Say we said, once you set it up, we said, okay, how about after 3 years? You could plug in number 3 and get your answer. Just make sure, guys, when you do this, all right, do what's in the parentheses first. So 1 plus whatever your rate is. If we're giving you years, after you do that, apply the years to what's inside the parentheses, and then multiply the 2 things. Right? So you're going to make sure you follow PEMDAS there. Add what's together inside the parentheses first, apply the exponent, and then multiply the 2 numbers together. That's how you do it. Alright? And again, we don't talk about order operations all the time. I just want you to get screwed up with that. Alright? So, let's look at an example. Again, write an exponential function to model the situation. Anywhere on that in that question, does it say solve?
No.
No. We don't have to solve. Let's read. The original price of a 1980 Corvette was $10,220, and the price increases 3% annually. Why couldn't I solve? Why isn't it possible for me to solve that?
Because there's no time.
Exactly. Good X. There's no amount of time there. So all I'm doing is just setting it up, and that's it. I don't have to do any more than that. If it doesn't give you the amount of years, you can't solve. Right? No, you all set? I don't know why you're making googly eyes at Sophie. I don't know what you two are doing.
Oh.
I'm not saying that, you're just staring at each other, what's going on? Alright, so, again, what am I gonna start with here? Jack, what am I gonna start with? Look at the formula you just wrote down. You don't have to mouth that, Joe, that's not nice. What am I gonna start with, Jack? On the formula, right, what's it say? That big box we just filled in, what's it start with? I don't understand what on the side conversations are about, it's okay. Hold on, everybody chill out. Because then test day will come around on Friday. Oh, Mr. Roy, I don't really know how to do this. Oh, man. Oh, jeez. Well, you should have paid attention now, so I don't feel bad. So pay attention. If you pay attention now, you'll be in good shape. All right? So, Jack, what am I starting with? Y. After Y, then what?
3%.
Before that. It's a sign. There you go. Good. Ginny, after that is what? In this problem, okay, good, you're correct. In this problem, what's A? Excellent. Very, very good.
They should put the dollar sign with that.
No, what's next? So we just did what? We just did Y, we just did equals, we just did A.
With the parentheses.
Excellent. After the parentheses?
3%.
No.
No. 1980.
Huh? Parentheses.
I wanna do it.
1. After the 1 is what, Noah?
R.
No.
30%.
No. You're skipping something. 1
Plus.
plus. Good. After that is what page? 3, but what am I gonna make sure I gotta do?
Point.
Point what?
03.
Very good. 0.03. One thing I'm missing. I can just put, again, we're not giving it, right? So what am I gonna put, X? That's all I have to do. Alright? That's it. Now, Mr. Hager added something. What's up, Joe?
Will it be 1980 for the time?
No, because 1980
That's
is
the
just
year
the
the car
year,
was made.
not the amount of years. So if we put that there, Joe, it's a good point, Joe. If we put that there, Joe, we would say that 1,980 years have gone by. Right? Again, that's this. Joe makes a great point. That's just the year the car was made, not the amount of years that have gone by. We want to know the amount of years that have gone by. So like Mr. Hager just put, right? What was the price in 2010?
10,220.
So
2016.
we have to figure out, Mr. Fairbanks, how many years have gone by since the car was purchased till this date?
38.
So 1980 to 2010.
Oh, 2000.
No,
30.
you are right saying that though, 38. If it was 2018. Alright, so now, what Mr. Hager did was, he went ahead and simplified. He just did 1 plus 0.03, and he got 1.03. Alright? We'll use this same thing. Y equals. Alright? And what's the new thing that I have to put? What do I know now that I didn't know before?
T.
Time.
Which is going to be what?
30.
30.
Then you do 1.30.
Yeah? So remember, when you do this, guys, listen. When you do this, like Mr. Hager did, he added what was inside the parentheses first. That's how we get the 1.03. Then you're going to apply the exponent. Then you'll multiply the two things together.
Are we done?
So, Mr. Hager got this. Alright? And again, we're dealing with money. So we're dealing with money, so how many decimal places should we have?
2.
So what should I write? 24,806.
Miss Brady said
Point what?
0.6224.
Again, it's money, so I only want 2 decimal places.
No, you just want to understand.
Alright? Now,
That's a lot of money.
You just don't. That's why your grades
what's the last?
No, that's it, Mr. Roy.
Oh, that's it? Oh, you already did it? Okay.
Typed in right here.
So guys, that's the mistake I was just showing you guys. He took the 10,220. Again, you can, if you have a calculator, you can do this.
Okay.
Times 1.03 on your. Anyone know what the calculator button on the exponent button looks like on a calculator?
Yes.
X with the 2.
No, you could do that, but that's only gonna work. That'll only work if the exponent is 2. What if you have a different exponent?
B with X.
Yes.
It's a little caret or upside down V. Right, that way, right there it is.
I do that.
If I want to do like 10 to the 3rd power,
I'll do it for you.
that's what it would be. Alright? That's how you use the exponent button on a calculator. Alright? That's what it looks like. Again, if you hit that little X to the X with the little 2, that's great. That's only going to work if every number you deal with to the 2nd power. We may have bigger numbers. Alright? So that's what that one looks like. Alright?
Are we going to be doing this on the test?
Yes. No, we're just doing it for the fun of it.
I said that there was your
Alright, so that's what the exponent button looks like. Alright, now. Alright, so now, another way that we can show exponential growth is compound interest. So this is another formula that we have to use. Did we miss example 4?
Yeah.
We missed example 4, Mr. I don't know what happened.
Yay.
Oh, there it is. It must have got switched around. I don't know why.
It's not there.
Ours feel like we're gonna hit the other bottom.
Well, they did the formula first.
What is it? It's the same thing. Oh, man. It's not good.
We're good.
Yeah, we missed 4 for some reason. I don't know why.
I mean, it is the same thing. Yeah.
It's the same thing. It's just not compound. Alright, so guys, let's just look at. Just want to do.
They need this first one.
Not for this one. Not for example 4. They don't. Because it's just compounded annually every year.
Yeah, just do the.
We're gonna skip it. We're gonna skip 4. So guys, for right now, we're just gonna skip. Example 4 and example 5 are the same. We're just gonna skip example 4 right now. We're gonna go on to example 5. So we're gonna fill in that little box that has all the little arrows and stuff coming out of it. All right. So guys, example 4, we kind of did that anyways. It'd be like y equals. I think it'd be like y equals 250 parentheses 1 plus 0.04 t.
Can we just cross it?
Yeah, you cross that out. All right. So now, so you deposit.
They gotta go through the formula first.
Yeah. All right. So compound interest, right? So, like, if you put money in a bank account, all right, every few days it earns interest. It's money the bank pays you for putting money in their bank. All right? And it can work both ways. All right? So interest from a bank, all right, they pay you because you're investing their money with them, you're putting their money with them. Now, Mr. Hager and myself, we both your parents, they own houses. All right? So we have to take out a mortgage to pay for the house. Because you're borrowing money from that bank, you have to pay them interest. So it works both ways. If you're putting money in an account with a bank, they pay you money back. All right? If you're borrowing from them, you pay them back. All right? So, here's what the formula looks like. So very similar, like we had before. All right? Y equals A. A is the same thing as what you start with originally. All right? You put, like I just opened a bank account for my son. All right? Yep. So money he got from his baptism, right? If we check this account today, it'd probably earn a couple bucks because. Yeah.
Wait, so when you have an account, they give you money?
Yes. They pay you. Like I said, they pay you interest. Yeah, if you have a savings account, whatever, they pay you money for putting your money in the bank with them. So like I said, it's not a lot of money, it's like cents.
Still,
Probably like 5 cents.
Alright? But like I said, it works both, guys, it works both ways. If you, like, take out a loan from a bank for a house, to do a project on your house, to buy a car, like my truck payment, I have to pay them back because I'm borrowing money from them. So if I borrow like, $5,000, it's gonna end up being like $8,000 and something cents because you have to pay. You're paying them money back to borrow the money. All right. So A is the same. All right. A is the same. It's still the initial amount. Everything else is the same. This is a little bit different now. So you're gonna have R, which is still gonna be your rate. Still gonna be a decimal. You're still gonna find it in the problem because it's gonna be a percent. N is going to be number of times interest is compounded per year.
Where are we writing this?
You're going to put it right here. So A, 1, N, R, N. So notice how we have N twice. We have N here and N there. N is the number of times interest is compounded per year. Alright?
Why do you need N twice though?
That's the way the formula works. Alright? If it's compounded annually, alright? If it's compounded annually, how many times does it get compounded per year? Annually. Yeah, one time, like X just said. If it's annually, it's once. Alright, we're gonna need anything else, Mr. Do we want to talk about quarterly?
Monthly is, I think, sufficient.
You want, okay. Now, if it's compounded monthly, how many times in a year? 12, right? So if it's compounded monthly, it means 12 times per year.
Why 12?
Huh? Because there's 12 months in a year.
You could do one under example 4 and one under example 5.
Alright? So, again, compounded per year. If it's annually, that's easy. It's just once. If it's monthly, alright, it's 12 times.
so that's the answer.
Not the answer, no. You didn't say anything up yet. Alright, we're just going through the formula. T, alright, T is still going to be time in years. Alright? Everybody with me? Are you with me? So, we'll do one. So, do you want this to be 4, Mr. Hager? This could be 5?
Sure, however they.
Alright, if you guys crossed out 4, that's okay, because, alright, example 4 means it's compounded annually. So it doesn't really change it too much. Alright? So, for this one, if I'm going to set up my exponential function, I'm going to start with, no mistake, you write that in. I'm going to start with y equals. What comes next?
2.
Fred, what comes next? How much am I starting with?
250.
250. Yeah. Chances are, for these type of problems, A is going to be the biggest number there. A is going to have the money attached. All right. So 250. I'm going to put my parenthesis. Jenny, what do I write next? 1. I'll write a plus sign. All right. Joe?
Where's those?
What's that, buddy?
Wait.
We want to do this as example 4.
Wait, in the left hand side, is that supposed to
I
be
already
this?
crossed the vehicle.
Huh?
In the left hand side, is that supposed to be this?
Look at
This is supposed to be that formula. Yes.
Is that R?
Hey guys, if you crossed out example 4, that's okay too. All right. Next is going to be what? X.
0.04
0.04, right?
over 12.
0.04. Now, for this one, it's compounded annually. How many times per year?
Wow.
1 time, right? Over 1. And my parentheses.
Oh, you have a year there.
So then N is going to be number of times it gets compounded. How many times? Once per year.
Yeah.
How many years? Okay, so for this, guys, I lied. We can just put this as T. Alright, because all this is asking us to do, guys, is just set it up. We don't have to solve, we're just setting it up. We don't have to solve yet. Alright, so that's what my exponential function is going to look like, alright, if I didn't know how many years. So for the exponential function, I'm just pretending that I didn't know, alright, after 5 years. Now, I know it's been 5 years. Alright, so a couple things are going to change.
Do you have to put the 1 in front of it?
No, you don't, but I think it'll make sense when you see it.
Everything here will stay the same. Y equals 250. 1 plus 0.04 over 1. How many times does it get compounded?
Once.
Once. How many years? 5.
Oh, I see.
1 times 5.
Make sure you don't look at the
Alright? Now, if I was going to simplify this, y equals 250. Again, 0.04 divided by 1 will just be 0.04. Alright? 0.04 divided, Mr. Hager's going to show you guys. Or he's doing the whole thing on the calculator.
Let me do it one step at a time.
Yeah. So y, so he's just going to do 1. See? So he just did 1 plus 0.04 divided by 1. 0.04 divided by 1 is going to be 0.04. So what I'm going to get here is 1.04. On the outside, what's my exponent going to be? 5. 5, right? So it's 1 times 5.
Now, at this next step, guys, just use a calculator and type it all in.
Yeah.
Some people round some things and don't. Just type it in exactly.
Yeah, once you get to it, and guys, you're going to want a calculator for this. This is going to be really hard to do. All right, this out freehand. So again, what's that button again, Mr. Hager? Oh, you just did it. Remember, that's your exponent button, right? The little caret. Here it is. Again, it's money. How many decimal points?
2.
So what should my answer be? What should I write?
$304.16.
Good. Y equals $304.16. Now, what would cause? I'm looking at this, right? What would cause me to round?
Nothing. Oh, it's the 6.
No, so again, I want to look at 2 decimal places. All right? I look at that 3rd decimal place. If it's 5 or above, that's going to cause this number to go up. But it didn't, it's 3. So I'll just leave it at 16, that's fine. All right? Now, we're going to do it compounded monthly. All right? The first,
Making coffee out of
everything's going to stay the same.
I don't have that.
So now, we're going to be on example 5 now.
Oh, I just.
So I know it's not broken down like this, but that's okay.
I just did number 5.
All right. So compounded monthly. What's going to change?
the end on the exponent thing.
Yeah. So the only thing that's going to change here is the n. Everything else stays the same. All right. We're still starting with 250. All right. 1 plus 0.04. Mr. Do we want to put everything in here and then we'll solve? Is that what you're looking for here? Yeah. Okay. So we're going to plug. So for the exponential function, we're just plugging in everything. We don't know. Let's pretend that we want to pretend we don't know the number of years yet. Correct?
Yes.
All right. So we'll put. Let me see that formula. We don't know the number of years. So what do we want to put an n here, Mr. Hager?
Divided by 12.
Divided by 12 you want here? Okay. Divided by 12. Here we want time, we don't know, split t, right? T times 12?
Or 12t.
12t. 12. So again, guys, here all we're doing is setting it up, not knowing the amount of years. What's up, Sidney? Huh? Again, I know, like I just told you, I know example 5 is not set up exactly like this. Alright? It's not like broken down exponential function in value, but that's okay. Alright?
We don't have fractions.
We don't?
Why not?
So now, the only thing that's going to change here is now we know the number of years. So everything y Actually, you know what? Yeah. Y equals 250, 1 plus 0.04, divided by 12. The only new thing we have to add is in for what? T becomes what? 5. 12 times 5. Again, I'm going to simplify y equals 250. Now, what Mr. Hager is going to do, guys, is, again, at this point, guys, you want to use your calculator for this. Do what's inside. He's going to do. Mr. Hager is going to do what's inside the parentheses on his calculator. There it is. We want to call that one, Mr. Hager, 1.0033. 1.0033.
Yep.
33. There it is. Let's simplify the exponent. What's it going to be?
3 or 4.
Let's simplify the exponent. I have 12. 60.
Oh, I thought.
At this point, what should we do? Everything goes in your calculator. What button do we use for the exponent?
Arrow button.
Oh, carrot. Oh, the arrow. That's okay. How you think of it? How are we gonna remember?
Not.
So it's just.
I'm not gonna make you do this.
What? Oh, God.
So what's our final answer gonna be?
$304.64.
$304.64.
So what do you notice if the bank compounds your interest monthly versus yearly?
It only goes up by
A little bit.
Yeah. So here, guys, here it is monthly. Here it is yearly. If the bank does it monthly, you're gonna get, I don't know, what, around 40 more cents. Something like that.
48 more cents.
48 more cents.
Not that much.
Not that much more. All right. And guys, I'll have space. We'll have space on your reference sheet to write those formulas. Couple things to keep in mind while you're packing up. Please listen.
Wait, what was the answer? $304.64.
Couple things. Homework. All right. 6364 worksheet. Pay attention to this. The reference sheet is going to be up on Google Classroom. I'm going to get it up at some point tomorrow. All right? You need to find a way. You have all day in school tomorrow. I know you're not going to be taking MCAS. You have access to printers in school. All right? Whatever problems I have you put on the reference sheet, they need to be copied down. Whatever formula I put on the reference sheet, whatever example, no, it's going to be on Google Classroom. But again, if you don't have those, this is like a two-part thing, because we have 2 days before our next class. If you don't have both of these things done, then you don't get full credit for your homework. Both things need to be done. All the examples need to be recorded on the reference sheet, and the worksheet needs to be done. If you don't have both things done completely, you won't get full credit for your homework. Again, no class tomorrow. We have MCAS. Here's the schedule for tomorrow: 5, 6, 1, 2, 3. All right. Pay attention to Thursday. We only have half a class. All right, another double block. We only have period 7. All right. We're gonna do a few more new things on Thursday. Test will be on Friday. All right. That's our last one of the quarter. Final exam, guys. It's gonna happen quick. We have one more academic week. All right. Then we have a week off. That's your last shop week, and boom, that day you come back from shop, the 18th. That's when your math.